In December 2021, humanity launched its most ambitious telescope into orbit. The James Webb Space Telescope, named for a former NASA administrator, carried a mirror the size of a tennis court folded into origami, 6.5 meters, gold-coated beryllium, cooled to -233 degrees Celsius. Its mission, to see the first galaxies ever born. Hubble gave us a glimpse. In 1995, astronomers pointed it at a patch of sky the size of a grain of sand and waited. 10 days of observation revealed 3,000 galaxies crammed into that tiny window. We learned the universe was far more crowded than we imagined, but Hubble saw visible light. It was like looking at a photograph taken with a flash at dusk. Webb sees in infrared. It peers through dust clouds that would be opaque to visible light. More importantly, it captures red-shifted light. When distant galaxies move away from us, their light stretches. Visible light becomes infrared, becomes microwave. The farther away, the older, because light takes time to travel. Webb can see not just across space, but back through time itself. In July 2022, Webb released its first deep field image, thousands upon thousands of galaxies. But something was wrong. Not broken, wrong. The universe looked too crowded, too mature, too old in the places where it should have been young. Let me name the galaxies that broke cosmology. See Ayers 93316. In 2023, astronomers discovered what appeared to be a galaxy born just 250 million years after the Big Bang. That headline lasted 3 months. When spectroscopic data arrived, they had to revise it to 235 million years after the Big Bang. Then again, to 1.1 billion years. The redshift kept shifting downward. But even at 1.1 billion years, Ayers 93316 was massive. Roughly the mass of our Milky Way. Our galaxy took 13 billion years to build itself. CRZ 93316 did it in 1.1 billion, GNZ 11. Before Webb, this was the most distant known galaxy. Redshift 11, an object born 400 million years after the Big Bang. When Webb looked at it, it still held that position. Confirmed, ancient, impossible. JADES GS Z140. In 2024, Webb's JADES survey team announced the oldest galaxy ever observed, Redshift 1422, born 300 million years after the Big Bang, over 1,600 light-years in diameter. In March 2025, the ALMA Observatory detected oxygen in JADES GS Z140. Oxygen, heavy elements forged in stars. The galaxy had undergone rapid star formation, rapid death, rapid recycling, all within 300 million years of cosmic birth. Within 300 million years. Then MOEM Z14 arrived, redshift 1444, even older, even more impossible. And these are not outliers. The SEE-ERS collaboration cataloged 88 candidate galaxies with redshifts between Z equals 8.5 and Z equals 14.5. 88. In one field. Many were bright. Brightness correlates with mass. Mass requires time to assemble. Time these galaxies did not have. The data is now robust enough that we must ask a difficult question. Does the universe actually work the way we think it does? The Big Bang occurred approximately 13.8 billion years ago. Not metaphorically. This is grounded in observations. Cosmic microwave background temperature, Hubble constant measurements, the ratio of light elements to heavy elements, the universe's expansion rate then and now. The calculation is overdetermined. 13.8 billion years. Give or take 50 million. A galaxy is not assembled instantly. It begins as a cloud of hydrogen and dark matter. Gravity collapses it. The first stars ignite. Massive stars burn hot and brief. When they die, they forge heavy elements. Carbon, oxygen, silicon, iron. A supernova shock wave crashes into neighboring gas clouds. Those clouds collapse faster. New stars form. The process feeds itself. But it takes time, billions of years. Our models show that a galaxy, the mass of the Milky Way, should not exist if it formed more than 10 billion years after the Big Bang. The universe did not have enough time to assemble the machinery needed for star formation at scale. Yet Webb observes galaxies as bright and massive as the Milky Way in universes only 1 billion years old. The cosmological timeline of galaxy formation is one of the most precisely measured phenomena in astronomy. We have precise dates. First stars, 100 million years after the Big Bang. First galaxies, 250 to 400 million years after the Big Bang. Peak galaxy assembly, 2 to 3 billion years after the Big Bang. Mature galaxies. 8 billion years after the Big Bang onward, JWST is observing mature galaxies in the era labeled first galaxies. It is like finding suburban sprawl where geological theory predicts only primordial ocean. This is not a measurement error, it is not contamination. Multiple independent teams have confirmed these redshifts using different instruments and methods. The galaxies are real. The timeline is real. The contradiction is real. Astronomers never panic. They theorize. Let me walk through the leading candidates. First, we misunderstand dark matter. In the current lambda cold dark matter model, dark matter halos form first. Ordinary matter falls into these gravity wells and collapses into galaxies. But this process is slow. Perhaps we need a model where dark matter halos assembled faster in the early universe. Perhaps the physics of dark matter was different when the universe was younger and denser. Modified gravity theories like MOND suggest that gravity itself behaves differently at cosmic scales. If true, galaxies might assemble more quickly than our equations predict. Second, primordial black holes. A small fraction of the early universe might have collapsed directly into black holes in the first millisecond after the Big Bang. These black holes could have seeded galaxy formation. A black hole's gravity collapses matter much more efficiently than cold, dark matter alone. Galaxies around primordial black holes might mature in centuries instead of billions of years. Third, early star formation timescales are wrong. We assume massive stars live millions of years before exploding. What if early universe physics made massive stars shorter-lived? Then the recycling of heavy elements would be faster. Galaxies could build themselves in less time. Fourth, the Big Bang age itself is slightly wrong. Not by much. Perhaps 14.2 billion years instead of 13.8. That 100 million year cushion might be enough to slip these galaxies into theoretical acceptance. But measurements of the cosmic microwave background are extraordinarily precise. This escape hatch is closing. Fifth, galaxy mergers happened faster. If the early universe was denser than we calculate, collision rates between small galaxies were higher. Mergers trigger rapid star formation. Many small galaxies assembled into large ones in rapid succession. This is plausible, but not yet quantified. Sixth, physics beyond the standard model. Perhaps particles we have never detected, in processes we have never imagined, operated in the first billion years. Perhaps they modulated how quickly matter collapsed. Perhaps they seeded structure more efficiently than cold, dark matter alone. This is the frontier. This is where genuine discovery lives. Webb is still observing. The James Webb Space Telescope is not finished. Over the next decade, millions of hours of observation time remain. Each pointing into deep space might surface new impossible galaxies, or might reveal that the early ones were statistical flukes or measurement errors. In 2027, the Nancy Grace Roman Space Telescope launches. Roman has a resolution intermediate between Webb and previous telescopes. It will survey vastly larger areas of sky and find hundreds of impossibly old galaxies. It will establish whether this is a real population or an artifact. The combination of James Webb's depth and Roman's breadth will map the galaxy population across cosmic time with unprecedented precision. If impossibly old galaxies are common, our cosmology needs rebuilding. If they are rare, we need to understand what made them special. Either way, we learn something profound. But there is something deeper here beyond the data. When you propose an observation that contradicts established theory, science does not dismiss you. It builds instruments to check. It dedicates billions in resources and years of engineering to verify whether you are correct. That is the strength of this method. That is why we keep building better telescopes. JWST found something the universe should not contain. Now we build new instruments to find out what it means. In the next 5 years, we will either overturn a fundamental pillar of cosmology or learn why these galaxies are even stranger than we thought. Either way, we will never look at the early universe the same way again. The universe refuses to fit inside our equations, and that is exactly when science becomes interesting. Comment Cosmos below to unlock our next deep field discovery breakdown. Thank you for watching Cosmic Report.